Hi everyone, welcome to the new lecture of code practice, and in this video we will talk about the integration of Micronaut with AWS Lambda. So let me give you a brief about what is AWS Lambda. So AWS Lambda is an event-driven serverless computing platform, right? And it's a managed service provided by AWS. So let's pose a scenario. We want to execute a particular request, and it is taking a like 5 minutes of time, right? And to use that on server, what we have to do is we have to bear the cost of that server, right? The server will go up and it will go down, and let's say if it is running on a 24-hour server, right, so we have to bear that cost of 24 hours, right? But using AWS Lambda, we have to bear the cost of only that 5 minutes for which our request is executing. So this is the profit, or I will say advantages, we are getting from the AWS Lambda. And we can increase our like CPU, memory and everything using AWS Lambda, right? So let's see how we can integrate with Micronaut. So let's create a Micronaut application. Let's use Java version, and this is the Lambda demo app, and let's download. Let me open this project. This is the sample application that we did earlier in our lectures as well, right? In our rest and the running the first Micronaut application, you can visit in the previous lectures as well. Now the dependencies are getting downloaded, and let's see, go to the build.gradle. So these are the dependencies which are available to us, and to use Micronaut that Lambda dependencies, what we have to do is we have to include this dependency. So this dependency will provide Lambda related functions to us, the utilities to us to use in Micronaut. So we will sync our Gradle. Now let's start. So basically Lambda is like a function. So here we will make our own function which will point to that Lambda function. So let's say greeting controller, greeting handler, right? And let me annotate with this introspected and extends Micronaut. So if you see guys, there's two classes, Micronaut request handler and Micronaut request stream handler, and these both are coming from io.micronaut.function.aws, the dependency which we recently added, right? Now what is the difference between these? So if we have streams of data, let's say I want to connect DynamoDB streams with my Lambda, then I should go for Micronaut stream request stream handler. And if I'm making a normal functions and I'm providing any string input, or let's say any input from the API gateway, then I can use Micronaut request handler. So let me input output, and let me extend the, so it has only one method which is execute. Let me override this, right? Now so I want to tell you guys like one thing. If you see the constructors here, right, there are two types of constructor. One is the default constructor, and one which is basically using the application context. So this constructor is used in Micronaut test. When we are writing JUnit test in our local, then this constructor comes into the picture, and this is the default constructor which is used in AWS. So if you define any string parameter here, then let's say, right, I'm giving a basic scenario, and let's say string name, right? Or let's do one thing. We generally injected our services in other classes, right? So if you try to do this thing, right, let's suppose this class exists, right? Then if you try to run this on AWS Lambda, then that AWS Lambda will throw an error because it expects a default constructor, and it will give us the error and it will not run. So that's why we don't use these things. And if you want to auto wire something, then don't do this in controller, right? So let me revert this. And this as well, right? Now we are saying we are receiving any input and we are printing this. So let's say I am saving input plus hello input, right? And also let me show you how we can inject the dependency in handler. So let's say this is my class. What I have to do, I have to annotate this class with singleton. So it will be a singleton bean and public void say hello. So lambda is called for greeting, right? Right, now what we will do is we will go inside our handler, private my service, and we will use @inject. So it will inject the object of my service class into this variable, right? Now let's run this or build this. So there is no build folder, right? So I will use gradle w clean build. See, this is the shadows jar. Right, and my service dot say hello, right? And let me run this again. Now I will tell you. So if you see, go to libs folder. If you see, there are two types of jar, three types of jar, right? This is runner, this is 01 and all -all. So generally when we build our application, we generally deploy this jar, right? But in case of Micronaut Lambda, we have to deploy this jar on our AWS Lambda. Why? If you try to deploy this jar, right, then these dependencies will not be injected and you will get null exception here, null pointer exception, right? So to avoid these kind of, and to have the dependencies in your classes, right, the injected variables and the services, so you have to use -all. Now how this -all jar is created? So we will go inside the build.gradle, and if you see this, this com.github.john wranglem shadow. So this is the shadow jar plugin. So which is, this plugin will generate the shadow jar for us. Basically shadow jar is hyphen old, and which will inject all the dependencies required for our AWS Lambda. Now let's go to AWS Lambda and integrate this in, and we will deploy this in AWS Lambda. So I will pause this video and will log in my credential into the AWS Lambda and will resume my video. So this is AWS Management Console. Now we will go inside Lambda and we will create a function, right? So author from scratch, function name is greeting lambda, and runtime we need is Java, so Java 8. Change default execution role, create a new role with basic lambda permissions, so this we need, and create function. So it will take time and it will create a lambda function for us. So first of all it will create a role, user role, right, with lambda permission. So our lambda is created, right, and we can test this lambda using this, go to the test, and this is the template hello world, and currently we don't have any handler here. So let's go inside the code section, upload from zip or jar file or Amazon S3 location. So whenever you are working in an organization, there you can deploy your jar on the S3 and it will directly pick from the S3 bucket and it will deploy your lambda. But here we are on our local machine, so we can directly upload from here. So we'll go to this upload and we will go inside the development section, and here lambda demo app, and we will go inside our build folder, then libs, and this -old.jar, right, upload this. Now it will upload this file, and this upload will depend on your jar size and your internet speed. So jar has been uploaded. Now we have to change this. So this is the default handler. Now what we will do, we will provide our own path. This is our, we will copy this first, we will edit this, and this is the handler. So we are saying to AWS Lambda that, hey Lambda, use this handler for execution using Java 8 environment. And now let's test this. This has our jar as well as our handler name, which is pointing to this lambda. So we will use new event. This is the hello world test, and here we can see the logs. So it is failed, an error. Okay, so we are sending the JSON, that's why, and we are expecting, let me code practice, right, let me test it again. So if you see, lambda is called for greeting, which is our service, right? This log has been printed, and in this return hello input. So here we have returned the response. We have just not printed, we are just simply returning the response. So this lambda has been called successfully. And if you see, we are only paying for the 15 milliseconds. So this is how, like, this is the response hello code practice, right? So this is the advantages we are getting from the AWS Lambda. So instead of deploying on the server, and which will we have to bear the 24 hours cost, or the let's say we are deploying again and again, the downtime and uptime, that much of cost. That's why this Micronaut Lambda comes into the picture, and it saves you lots of time as well as lots of infra cost. That's it for this video, guys. I have shared the findings that I have faced, like the shadow jar, and what are the things we should use while deploying AWS Micronaut Lambda. And also one thing, if we go inside the Micronaut launch, from here, function application for serverless, here as well we can download the project. Let me show you. If you go inside the build.gradle, then it contains all the dependencies that we added, the Micronaut AWS one, right? And it also contains the sample. So this is the request handler, and this is the output that they are providing, and this is the Pojo class that they are using. So I have defined I didn't use this app because it would be more easy for you, like what is the dependency that we are using and how you can inject a service into a handler. So these are the things which I have tried to cover up, right? And now in the next video I will show you how you can integrate API gateway endpoint into the Micronaut Lambda, right? So this is the just normal handler. Now we will integrate, we will make a get endpoint, and here we will define how to use the API gateway things, and we will return an response for that get endpoint in the API gateway REST endpoint. So that's it for this video, guys. I hope you like this, and if you like this video, do subscribe my channel and please share with your friends and family members. That's it for this video. Thank you.